In this video, we're going to look at the derivative of a quotient, and we'll be using the quotient rule. And just as in the derivative of a product, where that is not the product of the derivatives, the derivative of a quotient is not equal to the quotient of the derivatives. And I encourage you to look at the proof in the textbook. This video is going to show you how to use it, but I think it's important to know where the derivative of the quotient rule comes from. And so the formula, if you've got the derivative of a quotient f of x over g of x, it's equal to g of x times f prime of x minus f of x times g prime of x all over g of x squared. And with the product rule, since it was a sum, it didn't matter what order you wrote it in, but with the quotient rule, it's extremely important because we're subtracting here, and subtraction is not commutative. And so one way to remember this, instead of using the function notation, is to say it's the bottom times derivative of the top minus the top times derivative of the bottom all over the bottom squared. The most common error is to write the numerator in the wrong order. So let's get down and apply this. So even though this is an f of x equals, we'll let the numerator be f and the denominator be g. So f prime of x is going to equal the bottom times the derivative of the top. Minus the top times the derivative of the bottom all over the bottom squared. So we'll do our derivatives out. So I've got the x squared plus 2. The derivative of x squared minus 1 is 2x minus the x squared minus 1 times the derivative of x squared plus 2, which is also 2x. And I'm going to leave the x squared plus 2 in factored form, but I am going to simplify the numerator. So distributing the numerator, I can cancel out the 2x cubes. When I combine like terms, I get 6x all over x squared plus 2 squared. So you can see that the quotient rule is definitely a little more complicated because of the algebra involved. And so let's look at a scenario where we don't necessarily need the quotient rule. When you have a monomial in a rational function, when you have a monomial in the denominator, you are allowed to rewrite the polynomial, the fraction or the quotient into two separate fractions. So I'm not going to take the derivative yet, but I'm going to rewrite this as f of x is going to equal x to the 4th over x squared minus 3x to the 6th over x squared. I'm going to simplify that. F of x is going to equal x squared minus 3x to the 4th. Now don't forget, all we did was manipulate the algebra. We haven't taken a derivative yet. So now I'm going to take the derivative. It's just a polynomial. So the derivative of x squared is 2x. The derivative of, we've got a negative 3x to the 4th. It's going to be minus 12x cubed. So in this case, we didn't have to use the quotient rule. Just like in the prior videos, where if we had a factored polynomial, we could distribute, multiply it out, and use the sum rules instead of using the product rule. Okay. All right, let's look at example 8. And it says to use the quotient rule to show that d dx of x to the negative 3 is equal to negative 3x to the negative 4. So the first thing I'm going to do, I know that d dx of x to the negative 3 is going to equal d dx of 1 over x cubed. So I'm going to use the quotient rule. And basically in doing this, we're kind of showing that the power rule does work even if the exponent is a negative. But let's use the quotient rule to do that. So the derivative of 1 over x cubed is going to be the bottom times the derivative of the top, which is 0, minus the top times derivative of the bottom all over the bottom squared. This cancels out. In the numerator I get negative 3x squared. In the denominator I get x to the 6th. And using my rules for exponents, if I cancel that, I'm going to subtract the 6 off, and I'm going to get negative 2, negative 3 x to the negative 4. So even though we could have used the power rule on this particular derivative, we're basically just showing, using the quotient rule, that the power rule does work even for negative exponents. I'd like you to pause the video, really try it on your own, and then start the video again to check your work. Alright, for number 4, I'm going to first rewrite this as a quotient. So I've got x minus 4 over 2x plus 5. So f prime of x is going to equal the bottom times derivative of the top minus the top times derivative of the bottom all over the bottom squared. We'll distribute. We get 2x plus 5 minus 2x plus 8 all over 2x plus 5 squared. The 2x's cancel, so I get 13 over 2x plus 5 squared. Okay, I'll put the solution to the next problem in the next video. We're going to end this one here.